Hello everyone, this is Rocky Mahmood and welcome to the presentation on the paper Eco-Innovation and Power Performance, and it's a meta-analysis. And I am a PhD student who is doing his third semester of PhD at University of Southeastern Norway from Norway, and thanks for giving me the opportunity to present my paper here. So the paper is basically on eco-innovation and firm performance. And by firm performance, I'm focusing on the financial performance of the firm. So it has been one of the most investigated research topic within the areas of green innovation. Also, there has been lots of connections, lots of talks around the fact that whether taking an eco-innovation or green innovation approach has any benefits towards the farm, especially if we are looking at the financial benefits of it. So existing literature on this relationship between eco-innovation and crop performance presents an inconclusive result. So in some studies we can see that there is a positive impact of eco-innovation, and in some studies we can see the result is negative, or sometimes it says there is no impact of eco-innovation on the farm financial performance at all. So based on that, I think there is more research needed in these sectors or in this topic to understand whether eco-innovation has any significant impact on a firm's financial performance. So what do we mean by eco-innovation? Eco-innovation usually refers to the creation of a business process and the new products that has lower impact on pollution and contribute towards sustainability. That is kind of, standard definition of it is mostly innovation that is aimed toward reducing the environmental pollution and contributing to the other aspects like the social aspect and economic aspect of sustainability that we can actually consider an eco-innovation or green innovation. So there are three dimensions of eco-innovation that has been coming out from the existing research, and one of them is product eco-innovation, when the company is focusing on innovating products that actually reduces the environmental pollution. That could be a product eco-innovation. And then when companies are focusing on their business processes or maybe the production processes, in some processes, if they are involving some sorts of innovation that would ultimately give the output of reduced environmental pollution and somewhat contribution to the society, and it has some contribution to the economic benefits of the firm, we could consider those things as process eco-innovation. And then organizational eco-innovation, it talks about how companies are organizing, how creating relationships, and that could also create some sorts of benefit for the firm, that gives the firm an competitive edge, and also and it has another benefit that it would somehow contribute to the reduction of environmental pollution. So these are the factors. Based on that, actually, the research objective we had is to come up with a comprehensive knowledge to answer the research question that what is the financial impact of eco-innovation. So there has been some good amount of studies done on this particular topic. What I intend to do in this article, I bring out the existing articles and the if exercises, and based on that, I try to find out whether what is the overall conclusion of researchers on the firm performance, or especially the financial performance of a firm when they are involved in eco-innovation. So in order to do that, we actually did a systematic literature search on Scopus and Web of Science using several keywords like eco-innovation, green innovation, and then sustainable innovation. And also for the firm performance, we used firm performance, financial performance, and firm profitability. So it actually generated 486 articles. Then we have been refining it further based on different criteria. Like we selected the articles only from the business area and business management and accounting perspective, especially there is focused more only on the business aspect of it. Then English languages, and then we also looked into some of the journals that are not very well renowned. So we actually use the journals that are published in a very well-known peer-reviewed journals. That these criteria actually give us a result of 163 articles, which were used to select articles using the following criteria. So in order to select or being selected as an article, it has had to go through all this criteria. Like they have to explain the relationship empirically between the eco-innovation and firm performance, and also there should be some sorts of R family effects available so that we could use it for the meta-analysis. And then each study had to clarify and define the construct, eco-innovation and performance, that actually did not use a similar source of definition. We actually excluded it from this study. And then each study had to provide sufficient information to compute the effect size. So there is a formula to calculate effect size. So here is the formula that I have been using, but the whole process of data processing and collecting data, processing them have been done following Rosenthal and DiMatteo's paper on it's a meta-analysis. They have been talking about how the meta-analysis could help us getting an overall understanding of a particular phenomenon, especially when we're studying a relationship between two variables. So from the included study, relevant data includes, like, we took the R statistic, we took F statistic and T statistic, and sometimes also take the chi-square and P values, of course. Those are the necessary things that were collected from each of the selected studies. So we selected around 21 studies and we collected all the statistics from there. And these statistics were then we converted it into coefficient values using the following formula. So this is Fisher's effect size, which is equal to like 0.5 ln 1 plus the correlation coefficient divided by 1 minus correlation coefficient. That actually give us the effect size. We took these effect size, put it into the meta-analysis, and then we have done our data analysis, which gave us the following result here. So we used actually both the random effect model as well as the fixed effect model. So the random effect model and the fixed effect model, we see some difference. Like the random effect model is showing there is a positive relationship between farm performance and eco-innovation, but the impact size is like 0.12. Whereas we are looking into the random effects model, we find out the impact size is almost double of compared to what we have with the fixed effect models. And of course, the confidence interval label seems to be more varying more in the case of random effect model, as we can see from the result here from the forest plot. And then the common effect model seems to have like slightly lower variations. And of course, it seems like both cases are suggesting there is a positive relationship between the variables. But when we look at the I square, like the heterogeneity, we find out there is a presence of heterogeneity among the studies. And heterogeneity usually means that the overall impact size between the selected studies were not the same, and it has the heterogeneous impact. They are not at the same level. So what we had to do we had to find out whether we could reduce the heterogeneity. But before getting into that, we found out that like they took a bar chart plot of the meta-analysis to find out which studies or which data were actually, impacting the end result. So we found out the study number 19, 12, and 4, which are essentially the result of seeing it evolve, and Wang Wu and Iber Guzman. These are the three studies. They were having a significant influence to the heterogeneous result of the meta-analysis. So what we did, we actually tried to remove them and try to take out the heterogeneity effect of it. And so when we did in the first phase, we actually have been showing. So these are the all 21 studies, and we have the fixed effect model and you can see the effect size is 0.12 and the random effect model. So there's a huge variation between the two models. You can see that so the deviation from the fixed effect model to the random effect model is pretty high, and also the heterogeneity score is almost 98%, which is quite high. It's not within the acceptable limit. So what we did, we identified those three studies and we removed it in the phase 2, and still the funnel plot here is it's showing that um, the studies are still scattered. They would need farther, so the heterogeneity is not, it is lower, but it's not as low as we were expecting. It would have to be at least less than 0.5 or 50%. So in the phase 3, so when we did identified using the bar chart plot, we found out like 6 more studies that were having more influences on it. When we removed those things, we found out that, well, it goes beyond 50%, and it is an acceptable limit. And you can see that the result between the effect size of fixed effect model and random effect model is the same in the case when we are removing all the studies that were having significant impact on the heterogeneity. So overall, there are certain reasons for this heterogeneity, and we could use those reasons or we use this variable that was impact towards the heterogeneity of these studies. We could find out this could have a probable impact on the result of each of the selected studies in the sample. So we think, since these of the studies, I think these studies were taken from different areas, were done on different regions, especially some were done in North America, some were done in Europe, some of the studies were done in Asia, but there was some like 1 or 2 studies from South Africa, and then we have one from South America, and then the rest of the world, I think there was one study that was included in the sample size. So when we looked into the effect of region using a subgroup analysis, we found out that yeah, region really have a huge impact on the relationship between eco innovation and from performance. It seems like when we are looking at the first table here, it shows that the fixed effect model and the random effect model is all the same, and also if you look at the I squared, it's almost 0%, so there is no heterogeneity. And so in the European region, the studies that were concluded they were providing a more positive result towards it. So that means the companies that are investing in eco innovation in the European region, they were getting better from benefits. So they were having visible financial benefits by investing in green innovations. And the North American studies, it seems the fixed effect model and the random effect model, there is not much deviation between these two models, effect size, but The I squared is still a bit above the accepted limit, so it's almost 73%. So there are some heterogeneous results available within the region. So it might be a possibility there's companies within the North America that are investing in eco-innovation. Their farm performance might be somewhat dependent on the industry they were investing in. So that is a further issue for investigating. It could be a very good way to look forward and do some research on that field. And then studies in Asia, we see a huge deviation between the fixed effect and random effect model. And then, as you can see, the I-score result is almost 90%. So the heterogeneous effect is huge, and we could look into the further look into and do some research why it's happening here. Same goes for the region. We found that the region has some moderating effect, but it might not be as significant as the effect of region. So based on that, we actually reached to the conclusion. The meta-analysis reveals that eco-innovation is positive related to farm performance, and there is a moderate impact between these two. The European region eco-innovation pays better than the other region in the world, and then small and medium-sized enterprises they receive higher benefits from green innovations compared to the big corporations. And we have very little evidence available from South America, North America, and African regions. So more evidence from this region could further clarify the approximate quantitative effect on the firm's profitability. And then there are several limitations that might impact the interpretation of the meta-analysis. So including the time limit and low number of studies, then data collection is bad. Thank you so much.